Another really nice thing about this unit is that its application questions that we're going to do are very, very pertinent to your life. Things that are actually happening for many of you right now. The first thing that we're going to look at is compound interest, which is terribly fascinating right now. The whole world is going through stages of inflation, and as a way to stop inflation, governments have been raising interest rates. Now, usually, raising interest rates is bad for a lot of people. If you ask your parents, they're like, this is bad for us. Because most adults owe a lot of money. They buy things that they don't have money for. And most people don't have money for buying a new house. It's like, oh, let me just check my wallet. Oh, I have enough. I'm going to buy this house. No, that's not normally what happens. You don't have enough money, so you have to go to the bank and borrow money. And then when you borrow money, you have to pay interest. But as a student, most of you are, living at home, don't have to buy your own house. Maybe you bought a car, maybe not. You might actually have money in your bank account. And if you look lately, because interest rates have been going up, you might look at the end of the month and they might even be paying you interest. And that's super exciting, because getting money for free is always a good thing. So when the bank pays you interest, you're like, yay, I got money. So we're going to look a little bit about how does interest work, and what does it mean for something to be compounded? What is compound interest? Well, the idea looks like this. So we've got an example here. They have $100 into a saving account that pays 2% annual interest. And 5 years ago, I would have been laughing saying, you cannot find 2% annual interest anywhere. No banks are paying 0% and 0.00% interest 5 years ago. But now, today, 2% actually might be low. Most banks are going to be paying more than 2% interest on different things. So we're going to see, well, what does that mean? If they are paying 2% annual interest and it's compounded annually, the compounded part tells you when do they pay their interest. They're going to pay their interest at the end of 1 year. So if you had $100, at the end of 1 year, you would multiply that by, take 2% of 100 and add that on, and you would have started off with $100. Now at the end of year 1, you have $2 more, and life is good. Okay? And they've shown the math here that really adding the 2% is the same as taking that $100 and multiplying by 1.02. I don't know if you ever use that when you're figuring out something. You go to buy a new pair of shoes, they're $70, and you want to figure out how much taxes you're going to pay. You could take that 70 and multiply it by 1.13, and that would add the taxes right into there. The one part is saying, keep the $100 from before, and the 0.02 says, and add 2% more. Then, the way that compound interest works is the next year, you now have $2 more. So the next year they go, we're going to pay you 2%. We pay you 2% on the 100 that you already had, but we're also going to pay you 2% on the extra $2 that you earned. Super exciting, because instead of having $104, you have an extra 4 cents. You made 4 cents of interest on interest. And making interest on interest is what compound interest is all about. Now, if we look at the mathematics here, this one ends up being $100 times by 1.02 times by 1.02 again, so the 1.02 has gotten squared. And if you did this after any amount of years, you would have 1.02 to the exponent of t, which makes it an exponential graph, and we know that exponential graphs increase like this. So yes, at the beginning, it seems to be going only up $2. We're sort of at this boring part of the exponential graph where it's kind of flat. But if you go back far enough, it could make a huge difference, right? Just going back a couple of years, right? You're not going to have that much money. Like, ooh, you invested $100 3 years ago, and now you have $106. But let's say things go very well for you, and you happen to invent a time machine, and you can go back in time. And so you go back in time, and yeah, you hopefully be smart, because there's way better ways to make money if you go back in time. If you could have invested in Apple, blah, blah, blah. No, you haven't figured that much out. You're just going back in time to see your great-great-grandfather, and you're going to tell him, hey, I want you to invest $100 for me at 2% interest. And you go back, first of all, you go back 100 years. So at $2 a year, at 100 years, at $2 a year, without any compound, does it make sense that it should be worth around $300? Still isn't that exciting, right? You would have been way better to do something with Apple. But you haven't figured that out. But we're going to check. We're going to check here if you went back $100 times by 1.02 to the exponent of 100 years, instead of being just an extra $200, well, it's $724. Not that exciting, but better than $300. Now, had you gone back to see your great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-great-grandmother 1,000 years ago, look at what a difference that would make. E to the 10, we're already at like $39 million. Then it's really made a difference at the compound interest. It's simple interest, 1,000 years would be just say you get $2 every year, always the same. Compound interest does start to make a difference if you go back far. I think it would be pretty hard to find your great-great-great-great-great-great-great-great-great-great-great-great-grandmother. I thought, like, where would you look? And I don't think there's banks that would pay 2% interest. Yeah, just hold it there for 1,000 years. Anyways, this is compound interest. And the nice thing about this year, oh yeah, I want to do this. So that was compounded annually. But you could have compound periods that happen more often. So next they look at what would happen if you compounded something semi-annually. In other words, twice a year. So we already talked about you start with your $100, and in the first example you had to wait a whole year before they gave you your $2 interest. If it's compounded semi-annually, that means they're going to pay you interest twice a year. The first time that they're going to pay you interest is after 6 months. And the way that it works is they say, well, normally we would pay you $2 for the whole year. So after 6 months, how much should you be getting? $1. So after 6 months, they say, we'll give you the $1. And then after the 12 months, in other words, the whole first year, now they would say, well, now you have $101 in your account. 2% of $101 is $2.02. So after 6 months, you're able to get half of that. And so now after 12 months, you have $102.01. So if it's compounded more often, you make interest on interest more often. And in this case, it would come out to an extra penny for you. Very, very exciting. So the more often it's compounded, the more often you can make interest on interest. But, like, if they compounded something every day, they would say, well, normally you would get $2 for the whole year. We're going to take that $2 and divide it by 365, and after day 1, pay you that much. Yay, you made a penny over time that will make the total bigger at the end of the year, but only by a few cents. So you get the compound interest formula, and some textbooks use this formula, sometimes they like to use different letters. I think, for me, those are the most common letters that I've seen in other textbooks. Where P is the principal, the amount that you start with. In this example, they have A with a 0. R is the interest rate, and that interest rate you always write in as a decimal. N is the number of compounding periods per year. So if it said monthly, you would put 12 in for N. If it said semi-annually, you would put 2 in for N. And we have this formula. This formula is not on your formula sheet. So initially, that should cause some anxiety, like, do I have to memorize this formula? No. For this unit, they have decided not to put any formulas on the formula sheet. Instead, whenever you get a question, the formula will be included and every variable will be explained. So it's actually better than having it on the formula sheet, because if I give you this formula, I have to explain that A is the amount, P is the principal, R is the interest rate as a decimal, N is the number of compounding periods per year. So when you get to a question like example 3, this formula, either this form or the other form, would be given to you, and each of the things would be explained. So when you're answering this question, principal 1,500, invested 4%, compounded quarterly, to the nearest quarter of year, when will the amount be 2,500? We would know that the principal, you would plug in 1,500 there. The interest rate as a decimal, 0.04. Compounded quarterly, that's 4 times a year, so N is 4. And the total amount is going to be 2,500. You can plug everything into the formula based on what's given to you. The reason they took the formulas off the formula sheet is there are so many different formulas that could be used, and they didn't want to restrict it to 1 or 2. So you need to be able to work with any formula that's given to you and be able to manipulate. So could you plug everything in? Now, based on where we're at today, the only thing you know how to solve for is if you can get the bases the same. The base right here is 1.01. Is that on your powers chart? No. Nothing on here would be on your powers chart. So that means right now, we are not able to solve this unless we use a calculator. And what we're going to do right now is we're going to either use our graphing calculator or Desmos. We're going to put one equation into y1, one equation into y2, or in Desmos, we'll write y equals 2,500 for one equation, and y equals 1,500, 1 plus 0.04 divided by 4. To the exponent of 4x. Now, it should make sense to you that you don't see anything on your graph, because y equals 2,500 is a horizontal line at 2,500. So one of the things that we have to get good at with either a graphing calculator or Desmos is setting up our window so that we can see what we want to see. In Desmos, you can do that by clicking on the little tool button. And for my y-axis, I'm going to go here and change this to 3,000. Sure enough, my 2,500 shows up. My other graph is showing up, And I want to find out where these two intersect, so it's not hard to move it over here and see they intersect. If you click on one graph, the dot automatically appears, and you can click on that dot and solve that x, or in our case it's t, equals 12.8. 12.834. This question says round to the nearest quarter of a year. That's a weird rounding. Okay? The nearest quarter of a year to 12.83 is 12.75 years. However, based on the question, sometimes it will make sense okay? For this one, the way that it's worded, when will the amount be 2,500 to the nearest quarter of the year? This would make the most sense. If the question said to the nearest quarter of a year, when will the amount be more than 2,500? Can you see, if it hits 2,500 at 12.83 years, it would not be more at 12.75, then you would have to round up. So the rounding is sometimes tricky in these questions because you have to read it carefully to see what they're talking about. So 4% interest isn't crazy right now, okay? You could get 4% from different banks. This is telling you it would take you about 13 years to make $1,000 not doing anything. You just leave money there and you have $1,000 later. This is everybody's dream job, to make money and do nothing. Like, yes. Can I go to university? Better. Can I not go to university, somehow get a degree for that, and make money doing nothing? That would be wonderful. Hard to do, but interest is one of those places where you can make money doing nothing. The only thing that's a requirement, which is the hard part, is you have to have money to start with. So right now I'm trying to go around asking, hey, I would like to make money for nothing. Would you like to donate to that cause? I think it's a good idea. So if you just give me some money, then I'll be happier. I'm just not getting too many volunteers yet. Working on it. Okay, questions you can circle for this one. Are 12 and 13.